I'm Smith here. I'll be talking about probability. And probability, as someone has told, it's measure of uncertainty or making common sense, quantifying the common sense is called as probability. So let's talk about this case. Before going into the question, let us talk about a few situations where probability can be used in our day-to-day life. Okay, so I have a tool which is Desmos, which I'll be sharing with you. Let us go to our basics of probability. Here there are a few questions which I would like you to read, and let us read together and answer these questions first, which are basics of probability. Now here shows how it works. You will spin the spinner. How do you win? That up to you. Spinner lands on red, you win. Spinner lands on blue, blue win. So which option do you want to choose? Yes? Yeah. So let us choose the probability of more win, which is win of red. And why do you think you will win? Because the chances of you win is 75%. So this is how we can share with the class. I hope all of you got the answer. The probability of blue winning is only 25%. Now let's spin it and check. Yeah, you lose. So this is how we can gamify the probability topic with this Desmos 2. Now one more try. Win of red. Again, as the chance is 75%, I'll go with red. And next, let us try to spin. Yes. Now see the result. There are total 36 spinners. In that, 24% or 24 out of 36 are by red. Because the probability of red being selected is 75%. Okay. So similarly, and you can see only 25% is blue getting win. So this is how is the game of chance or probability. Now we have quantified it in this beautiful game of chance. So land of red again because it is 75%. Now this is how we can use this amazing tool to quantify. Now there is one more activity. How likely is each event drag the movable? Now impossible is 0, less likely, equal likely, more likely, and certain. Lands on red. So I'll drag it. Is more likely, and here they are less likely. And see, yes, land of red 17 and blue is 14. So this is what we can try out few interesting activities on Desmos. Now let's go back to our topic of Bayes theorem. Now before landing into this, I have few things which we can share here. Now, when we talk about basics of probability, we have to go step by step. Now, for example, if I have a box, okay, you can see this box which has 3 black ball and 4 red ball. Then what is the probability of you getting a red ball? What is probability of red? Can anyone share with me the probability of red? Yeah, probability of red is 4 out of 7. This is the very basic topic of probability. So out of 4 red balls, total number of balls is 7. The total favorable outcome by all the possible outcomes. We get red. as 4 by 7. The second case where I have similarly, I have in a box of 3 black ball and 4 red ball, and there is one more box which contains 5 black ball and 4 red ball. Now my question is, what is the probability of you getting a red ball from box number 1? So this is box number 1 and this is box number 2. What is the probability of you getting a red ball from box number 1? So we are going in a reverse way. So that's why this is application of Bayes theorem. When we go reverse, like cause and effect problem, we also call Bayes theorem as cause and effect problem. Now you getting probability of red ball from bag number 1. Okay, similarly, this is the probability of red ball from bag number 2. And you selecting any of the box, what is the probability? Yes, the probability is nothing but half. Okay, so this is one of the application of Bayes theorem which we'll be discussing in today's topic. Now, Bayes theorem is very important topic for IIT JEE, all the competitive exams, and also for CBSE 12th standard board exam. You will surely find a question from Bayes theorem. Okay. Now we have to understand when to use the Bayes theorem. If we don't know that, it will be difficult for us to apply this Bayes theorem. Now, what is the probability of you getting the red ball when it is from bag number 1? Okay, now we'll discuss this in further few more questions. So let's move on into the question which is next. Now it is like similar to, I'll give you a few examples when we can use this Bayes theorem. If there are, now you can see the weather, it's very cold here. So you can get sick, okay, either by cold or COVID, or you drank some cold water. Okay, now the thing is, my question is, you have got sick. What is the probability that you have got through COVID? Okay, that is going reverse. Okay, similarly, if a man has a cycle, bicycle, and a motorbike and car, now he met with an accident. And my question is, what is the probability of he meeting with accident with his bike? So we have to look these kind of questions in reverse. That's why we call it as reverse probability or Bayes theorem. I'm sure all of you got an idea where we can use this Bayes theorem. Any questions till now? No questions? Okay. Now let us read this question. The question is, a bag contains 4 red and 4 black ball. Another bag contains, it's a similar question what we had discussed earlier. 2 red and 6 black ball. One of the two bag is selected in random and a ball is drawn which is found to be red. Find the probability that the ball is drawn from the bag number 1. Okay. So already the event of red ball has occurred. Now we need to find out what is the probability that it is from bag number 1. So let's think for a while and ideate in this question. We have got the bag as the ball as red ball. Now we have to think about what is the events which has occurred, and it is from bag number 1. So let's ideate in our next slide. Yes, the same question. Let us note it down and ideate this question. So the question here says you that when we look to the end of the question, probability that the ball is drawn from bag number 1. Okay. Probability that the ball is drawn from, the red ball is drawn from bag number 1. It means what? You have, it is from bag number 1, the red ball is drawn from bag number 1. This is what we need to find out. So by Bayes theorem, which you can see in my previous blog, we have done in detail the derivation of Bayes theorem and how we can apply Bayes theorem. So we'll directly go into the formula. Do anyone remembers the formula? Okay, if you don't remember, if you have not remembered, then let us write the formula. Probability of B1 such that it is from red ball, red ball is equal to probability of, it is just reverse of this into probability of B1 divided by, same thing you will write in the denominator, probability of R by B1 into probability of B1 plus probability of R by B2 into probability of B2, because this is the total probability, or this is nothing but probability of B. Okay, so let us replace all these values what we have. Can you tell me what is probability of R by B1? Anyone? Probability that you getting red ball from bag 1. Now, for understanding this, let us draw another approach here. This is my sample space, and let us divide into two partitions. The first is bag 1, the second one is bag 2, and my event is you getting a red ball. This is my event. What is the probability that you get a red ball from bag 1, which is 4 red and 4 black total, so the probability is 4 by 8 here. Similarly, 2 red and 6 black, so it will be 2 by 8. Is it clear? Red ball from bag number 2. If we make this partition, this is my sample space. And this is my event of getting red ball. Make this partition, it becomes easy for us to, and you getting from bag 1, the probability is half and half, because they have not given that any chance. So we will take it as half. Now let us replace in this formula. Probability of red ball from bag 1, which is 4 by 8, in the probability of bag 1, 1 by 2, by, same thing you can copy it down, plus probability of red ball from bag number 2, which is 2 by 8 into 1 by 5. Now if we take 1 by 16 common in numerator and denominator, we are getting as 4. Yeah, 1 by 16, 4 by 1 by 1 by 16, it is 4 plus 2. We can cancel 1 by 16, 4 by 6, or it is 2 by 1. So this is the final answer, the probability of you getting red ball from bag number 1. Probability of you getting red ball if the event, red ball event has occurred. I hope you have understood this question. Any doubts? Okay. Now let's move on to the next question. You can copy down. You can visualize the problem with this sample space. Now let us go into a different set of question where the probability. Now let us go to the next question and visualize it. I'll erase this. I hope all of you are noted down. Okay, now the next question. Yes, add to full screen. Yeah, the question is, in a college, it is known that 60% resides in hostel. Previous result, previous year result reports that 30% of hostel students and 20% of day scholars attain A grade. At the end, one of the students is chosen at random and found to be who attain A grade. What is the probability that the student resides in hostel? Now let us draw a sample space divided into two even. One is hostel, which is how many students are staying? 60%. Okay. Now the event is, if 60% are staying in hostel, then obviously we have here 40% who are staying in day board. And the event now is attaining of A grade. Now, according to the question, 30% who stays in hostel attain A grade, and here 20% gets A. Now, let's write the base theorem. Find the required probability that the person attains A grade and is taking hostel. What is the probability that the student resides in hostel? This is what is the question. The probability of A by H into probability of H whole divided by probability of A by H into probability of H plus probability of A by B into probability of B. I hope it is clear. Now let us put these values. Probability of A by H, A grade, and his staying in hostel is 30%. Into probability of H is here. The probability is given as 60%. So it is 60 by 100. We cannot take it equal like half. It is given 60%. Then we have same thing value of here into 60 by 100 plus we have 20 by 100 into 40 by 100. If we take 100 square common, here we have 1800. That can be cancelled, both denominator and numerator. We have 1800 plus 800, which is 1800 by 2600, and still you can cancel 39 by 4. This is my final required answer. I hope it is clear. Any doubts, students? Okay, then let's move on to the last kind of questions. Yes. Please read the question.
What is it?
Ma'am, I'm taking a video. What is it? 9th and 10th.
Will it same class?
No.
It's different.
So the question is, in answering an MCQ, the student either guesses the answer or knows the answer. Either guess or knows the answer. Let 3/4 be the probability that he or she knows the answer, and 1/4 be the probability that he or she guesses. So guess is 1/4 and knows the answer is 3/4. Now, assuming that the student who guesses the answer will be correct, will be the probability of 1/4. Now, guess and will be correct is 1/4. The event is correct. Then, what is the probability that the student knows the answer, given that the answer is correct? So, the probability that the student knows the answer, given that it is correct. Knows the answer, given that it is correct. So, what do you think, students? What will be the probability that he knows the answer and he is correct? What will be this event? It will obviously be 1, because if you know the answer, it will obviously be correct. Now, to find out this, probability of C by K and probability of K by same thing, you can copy down C by K into probability of K plus probability of G by K into probability of K. So this is C by K, knows the answer, correct, and it is, which is 1. Probability of K is, what is the probability of K? Is 3/4. Same thing, 1 into 3/4 plus guess and correct, it is 1/4 and 1/4. Now, if we simplify this, we cancel 1/4, we'll get here 3/1. Then let's say 1/4 we take common. Here 1/4, 3 plus 1/4, so which is 3/1 into 4/7. 4/7. This is my final answer. Now, it is 13. This is 13. We get 12/12. Yeah. With this, we complete all the questions. Yes, I hope you enjoyed the class. If you have enjoyed, please do like, share, and comment.